Today, we'll be talking about water and the properties that make water unique. This lesson was made by Mariah Thrush and Andrew Copley as part of Ohio University's NSF-funded Boat of Knowledge in the Science Classroom. Gauge what you know first. Take some time to write down what you know about water, especially chemical and physical properties of water. Pause the video and write down anything you know. Here's a few properties you might have written down. The chemical formula for water is H2O, and the water molecules connect via hydrogen bonds. Water exists as a solid below 0 degrees Celsius, as a liquid from 1 to 99 degrees Celsius, and as a gas above 100 degrees Celsius at normal pressures. It expands and is less dense as a solid when compared to liquid state. It's called a universal solvent, meaning it can dissolve many materials. Water also has high surface tension and capillary action. It's okay if you didn't list all of these because they will be covered in the lecture. Water is an abundant resource on our planet. What percentage of the Earth's surface is covered by water? According to the United States Geologic Survey, 71% of the Earth's surface is covered in water. That 71% of water is not just blank space. It holds lots of life between oceans, lakes, ponds, rivers, and wetlands. Even terrestrial organisms rely on bodies of water or groundwater to survive. At the molecular level, water is made up of 2 hydrogen atoms and 1 oxygen atom. The chemical symbol for water is H2O. The molecular structure of water is bent at an angle of 104.5 degrees rather than a straight line. Why is the molecule bent? Think about your knowledge of electrons in each of these elements. Pause the video and take a few minutes to brainstorm with your classmates. To put it simply, water is bent because of polarity. The hydrogen atoms are slightly negative and the oxygen is slightly positive, which forces the oxygen's electrons away from the hydrogens and closer together. The oxygen's electrons are repulsed, remember, like charges repel, and push the hydrogen atoms together. Because of the uneven charge of a water molecule due to polarity, hydrogen bonding occurs between the hydrogens and oxygens of different water molecules. The word bond in this case is misleading. It's not a bond in the way there are covalent and ionic bonds. Instead, hydrogen bonds can be thought of as weak attractions between slightly positive and slightly negative parts of molecules and/or ions. Water molecules don't just attract to other water molecules. They can attract to different types of molecules, which makes water a universal solvent. A universal solvent is simply a term to describe how water can dissolve a wide variety of materials. It's important to remember that universal solvent doesn't mean that water can dissolve everything. Think of how water and oil don't permanently mix. But water can dissolve many materials, making it a good choice if a material needs to be dissolved. In this picture, the white and red molecules are water molecules. Hydrogen bonding attracts the sodium and the chloride ions to parts of the water molecule, breaking apart the sodium chloride salt. Water occurs in nature in 3 different states: solid, liquid, and gas. The states can change depending on different pressures and temperatures. It's pretty unusual that all 3 states of matter occur naturally on the planet, from glaciers to lakes to steam vents. Most other chemicals and compounds have to be converted to different states in non-natural laboratory settings. The density of ice is another peculiar property of water. Most solids tend to be denser than the liquid, but solid water, known as ice, floats in liquid water. This is because hydrogen bonds cause ice to not pack as tightly as liquid water. This is good news for fish and other aquatic organisms that live in cold climates. Why would it be bad if ice sank to the bottom of water bodies? Pause the video and talk with your classmates. If ice sank, it would displace water out of water bodies. Fish and other organisms wouldn't survive because they would be crushed by ice. Cohesion is the phenomenon allowing the water molecules to stack up on the penny without breaking or falling off the penny. It's important to note that cohesion is the phenomenon behind high surface tension of water. Hydrogen bonding between the water molecules is key to high cohesion surface tension in water. Hydrogen bonding is responsible for water being particularly attracted to certain substances, like the plant stem in this example. Have you noticed how hydrogen bonding is a very important characteristic of water yet? Let's do a quick knowledge check. In the picture, there are green and red bonds, indicating two types of bonds we've learned about, cohesion and adhesion. Pause the video and categorize the type of bonds. The red lines represent cohesion because cohesion occurs only between water molecules. Adhesion occurs between water molecules and different substances, such as the water and the solid pictured. Capillary action keeps plants alive and causes a curved boundary when measuring water in a graduated cylinder. This is the result of both adhesion between the container walls and the container, and cohesion between the water molecules themselves. You should realize that even though capillary action works against gravity, the weight of water will overcome capillary action, and gravity will cause the water to fall back down. Specific heat capacity is the amount of energy, in this case heat, needed to raise the temperature of a material. The specific heat of water is very high, meaning it takes a lot of energy to raise the temperature in a container of water. Why would fish love the high heat capacity of water? Pause the video and brainstorm with your classmates. Temperature fluctuates little between day and night and changes slowly during seasons, so fish and other aquatic organisms have enough time to adapt to temperature fluctuations. It's not just fish that benefit from high heat capacity of water. Towns on the coast of oceans and other large bodies of water have more stable temperatures and experience slower temperature changes than inland towns because the high heat capacity of water helps regulate the temperature. Let's recap what we've learned. What are the 6 properties of water we covered? Pause the video and make a list of what you remember. If you're having trouble remembering all 6, try to think about how they all associate to hydrogen bonding. Thank you for watching.